Happy Mole Day, y'all! We are in the middle of a little series I'm doing on how to teach difficult topics in secondary science classes. And when I planned this series, I just knew this week's episode had to be chemistry. And stoichiometry is arguably one of the hardest units to teach in chemistry. Students are terrified of it. They've heard horror stories from the classes before them. They think the math's boring. And honestly, it can get tedious having to do so many practice problems over and over again. So today, in honor of Mole Day, I will be sharing my best tips for teaching stoichiometry in your chemistry class. Let's dive in. This is Secondary Science Simplified, a podcast for secondary science teachers who want to engage their students and simplify their lives. I'm Rebecca Joyner from It's Not Rocket Science. As a high school science teacher turned curriculum writer, I am passionate about helping other science teachers love their jobs, serve their students, and do it all in only 40 hours a week. Are you ready to rock the time you spend in your classroom and actually have a life outside of it? You are in the right place, teacher friend. Let's get to today's episode. Now, today's episode is for my chemistry teachers listening, but as I have said all month long, I do have something for everyone, and that's my Halloween science freebies. There's one for biology, anatomy, chemistry, and physics. If you head to itsnotrocketscienceclassroom.com/Halloween, you can grab these 4 free Halloween-themed science resources. They are perfect to use over the next week or so. Now let's talk about teaching stoichiometry, which you most likely aren't teaching until later this year, which is yay, that's great. You have time to prepare now. I'm going to share 6 tips with you that I think will be helpful as you're planning out how you're going to teach stoichiometry. And for a little context before we dive in, stoichiometry for me and my scope and sequence of my chemistry curriculum, it falls as the first unit after winter break. So it's going to be what we're going to kick off the new semester with in January. It's unit 6 of 10. So just to give you some context. All right, now here is my first tip. It is to teach dimensional analysis and scientific notation early. Now, I know there's some controversy with this. I know there are a lot of teachers that say, don't start your year off with this. It scares them away. It's overwhelming. Why do all this math at the beginning of the year if they're not really going to need it until later in the year? And I totally hear that argument. But on the other side of it, here's my thought. Don't let the first time they see all of this be in the context of stoichiometry. Like, how scary would that be if the first time they're doing a unit conversion, it's from molecules to grams? Okay, it's too much. And they're using these giant numbers and there's no context. They don't even know what a gram really is, let alone a molecule or a mole of something. Okay, so I personally like to start the school year with dimensional analysis and scientific notation in my introduction to chemistry unit. Now, obviously, we're 3 months into the school year. So you're like, well, Rebecca, we haven't done it yet. So what are we supposed to do now? If you have not introduced this concept yet, I recommend I have a fudge lab activity. It's a great little lab where basically they get the recipe for making a single serving of fudge from their grandma, and she wrote it in crazy units and numbers. They have to convert out of scientific notation into standard notation and then convert it into usable units like teaspoons and tablespoons and drops. And, then they actually can make it in the lab and eat it. And I have an expansion pack of this. I'll link in the show notes. It's almost like a mini unit where I just pulled out my notes from my physical science curriculum on dimensional analysis and scientific notation. I have a quiz in there and some practice handouts, and then you get this fudge lab. But it's all in there. But so you could kind of do that now if you haven't done anything about this yet. But I really want to urge you, do not wait until you start Stoic to introduce dimensional analysis and scientific notation. This is one of those things, y'all, they need to see multiple times because it feels really overwhelming at first. I also feel really passionate about making sure you introduce it in a meaningful real world context. This is why I love using this fudge lab because they're not thinking about chemistry. They're thinking about making fudge. And let's be real. Personally, I use dimensional analysis daily as I cook or as I host. I love to make Chex Mix, for example, for the holidays. Every year for Thanksgiving and Christmas, I make homemade Chex Mix. And I'm standing there in the store aisle, in the cereal aisle, looking at the checks. I'm looking at the nutrition label. I'm seeing, okay, how many servings is in this box? I'm converting that to how many I need for my recipe, and I'm figuring out how many boxes I need. Y'all, that's dimensional analysis on the go, on the fly. Okay, so if your students are going to make food for any amount of people other than themselves at some point in their life, they're going to be using this type of thinking. So why not teach them dimensional analysis in the context of cooking, since that's how they're going to most likely use it in the real world? And then, because we're introducing this early, we'll bring it back to stoichiometry later. I really think introducing it in the context of food makes it so practical. And remember, we're really just trying to teach them a thought process. I say this all the time when it comes to chemistry. Teaching chemistry is really teaching problem solving and critical thinking. You're teaching them how to think differently. It's not as much about this content and this memorization. It's teaching them how to think a certain way so that they can solve any sort of problems in any sort of context with not necessarily needing that much information. Like, you can teach them intermolecular forces and, chemical bonds and maybe like 3 other things. And they can basically apply that and all of this type of critical thinking skills to so many different chemical contexts. So I really want to encourage you to introduce that early. Please don't let the first time they see scientific notation be in the context of learning about the mole and the number of atoms. Okay, so maybe you're doing something about the mole today or this week for mole day. That's great. That's at least hopefully 2 months before you bring it back up again. That's really important. So I really want to encourage you to introduce it early. The second thing I will say is then I want you to review dimensional analysis and scientific notation when you start teaching your stoichiometry unit, but before actually diving into stoic specific conversions. Okay, so again, I start stoic after winter break, and the very first lab activity they do, we haven't taken notes, we haven't done a single thing, will be a hot chocolate lab activity. It is a different version of the fudge lab. It's like the same exact context, but this time they're going to make homemade hot chocolate. They're going to do the scientific notation, the dimensional analysis again. But again, we're doing it in a safe place. We're doing it in the context of food. We're not talking about moles or atoms yet. Okay. Do that first. Bring it up again first before you bring it into stoic. Don't just go cold turkey. I taught it in August. Now I'm going to bring it back up again in January. Dive head in and grams to moles. They're not ready for that. Okay. And I have a version of this homemade hot chocolate lab activity that's a freebie. It's a seasonal freebie for winter. So right now I know I've been talking about the Halloween ones, but winter's around the corner. And this one is a holiday hot chocolate. So it's a little bit more seasonal. And you can grab that at itsonrocketscienceclassroom.com/winter. But I really recommend at least starting with that before you dive into your stoichiometry unit. Okay. My third tip is please start your unit by helping them understand the mole. And maybe you're doing that today, and I'm so glad. Maybe you're using Mole Day to really help them understand and try to wrap their minds around the quantity of a mole, because it's so abstract to them, y'all. They don't understand what a mole is. Hopefully we can help them understand why it matters. Like, hey, we're using so many of some really tiny things, which is why we need to make these numbers more reasonable, which is why we use the mole. But helping them understand it is so critical. So even if you're bringing it up today, please just kind of do something else again come January or whenever your stoichiometry unit is, to kind of refresh their memory on what a mole is. I have an activity in my stoic unit called the magnitude of a mole, and students basically draw cards and they get 2 different things and they have to figure out the conversions and do some research to figure out how much of that is this in terms of what the magnitude of a mole is. And the cool thing is I have so many different cards that no 2 students will have the same combination of cards. So they're all going to do this little activity and this little mini project differently. So for example, they may draw a card that says, puppies, and they may draw another card that says, Olympic size swimming pool. And their job is to figure out how much is 1 mole of puppies in an Olympic size swimming pool. Okay. So that's what they're kind of trying to do here. They're trying to put quantities around how big a mole is using things that they can actually visualize in the real world. I really just think giving them some sort of visual will give them context. Again, for all of this scientific notation they're doing, we're not just moving decimals, okay? We're trying to understand these giant and also really tiny numbers. So please start your stoic unit off helping them understand what a mole is and giving them some context for that. My fourth tip for teaching Stoic is scaffold it. Please, y'all, scaffold it. Please don't spend 30 minutes doing all of your stoichiometry notes and all the different types of calculations and then sending them off to do a packet of practice problems. Okay. I give them a mole map. I have a reference sheet in each of my chemistry units that I personally will let my students use throughout the unit and then later on the test. But basically on that reference sheet, there's a mole map that says, okay, if you're given moles, here's how you get to grams. If you're given grams, here's how you get to moles and vice versa. It kind of gives them, again, a map of where to go from here. But then I break down the Stoic calculations into 4 types. We start with mole to mole. We stop and practice. Then we come back and do mole to gram, stop and practice. Grams to mole, stop and practice. Grams to gram, stop and practice. And I really recommend teaching it this way. Anytime I'm teaching something that's like very much direct instruction, which if you all follow or use It's Not Rocket Science resources, you know I love a good inquiry activity. I love it. I love it so much, especially like a guided inquiry activity, kind of like a POGL. That's like my thing. I love it. But sometimes you just got to do that direct instruction. And with these calculations, I think it's the most helpful. So I like to do direct instruction with an example all together as a class. Then in the notes, I like to build in 2 to 3 practice problems that they're going to do with a neighbor. I call it their next door neighbor, whoever they sit by. And then they're doing this all in their notes. And then we're going to go over it together as a class and they can correct it in their notes. Then and only then do I send them out to do a practice handout or homework problems or whatever on their own. And when I send them out to do any sort of practice page like that, like a worksheet on their own, I like to give them time by themselves first to get started. And then if they can do that first chunk of time by themselves without talking, then they get the remaining 10 minutes with a neighbor or something like that, depending on time. So maybe they're getting 10 minutes on their own, 10 minutes with a neighbor. And I think this is really important because when you give them a practice problem and you send them out and let them work with a friend, one person may just take over and then the other person is just following it and writing it all down. And they're never kind of forced to really try on their own. However, when you send them out on their own first, with the reward being do it by yourself first, then you get a partner, it motivates them to really try. Let's let them get started. And if you're using radar, which is a problem solving technique that I talk a lot about, I'll link a blog post in the show notes about this. I feel really passionate about radar. I talk about it in chemistry, in my chemistry curriculum so much because I don't know how I would teach chemistry without it. But if you're teaching them radar, even if they can't solve the entire problem, every student in your class should be able to get started and do something. Even if they're just setting up the problem for all 5 of your practice problems or all 10 of your practice problems, then when they get with a partner, they can look and be like, okay, did you set yours up like mine? Where do I go from here? And then they just kind of get the next step as opposed to just copying all the practice together. So that's kind of how I always break up doing practice problems, especially with something that you need direct instruction on. And I really encourage that with Stoic and really break it up into 4 chunks to build their confidence. Like if you just do it all and then you throw them out and they're doing, moles to grams or grams to grams, they're going to be so overwhelmed. But you started off like, let's just do moles to moles. This is a baby step from what they've just been doing with dimensional analysis that hopefully they've now seen multiple times throughout your year. Okay, then we're going to kind of stretch it a bit. Now let's do moles to grams. Ooh, let's see if we can go the other direction. Okay, and you keep building on it that way. You really need to scaffold teaching these calculations. My 5th tip is honestly, do some fun things with them. I realized after I wrote my Stoic unit that I had 3 different labs that involved food. And I kind of joked with my husband, like they're going to be eating their feelings, like while they, process through all of the trauma that is stoichiometry calculations. And obviously I mean that in jest, but it's true. Like they're going to look forward to these labs where they get to eat if it's going to help take the edge off of doing all the math if they're nibbling on an Oreo or drinking the hot chocolate they just did the calculations for to make, or if they're making s'mores in your lab. These are going to be memorable experiences. And especially again, this is falling in January for me. I love to go outside. Can't do that in January. So these kind of make these labs a little bit cozier, a little bit more fun. You can find lots of different things like this on the internet for free. And of course, I have all these different things in my unit as well. But I really recommend doing some labs like that. Yes, I have a lab at the end of the unit where they make homemade chalk. Yes, that's very cool. Yes, they're going to go outside and it's going to be freezing, but we're going to try it anyway. But don't just only do labs like that where they're making a rocket or making an airbag or making chalk. Like, let's do some things that are like maybe editable or maybe a little bit more fun. Okay. I think the editable labs will make it a little bit more enjoyable for them. Okay. And then my sixth and final tip for you is make it meaningful as best you can. As many real world scenarios as possible. I think oftentimes we are afraid to give our chemistry students word problems because they think word problems are too hard. Like if they see a word problem, if they see like a paragraph of information, they're like, it's too much and they just want to skip it. When in reality, a word problem can actually be easier because it's going to give them meaning and context for a situation. And it's great practice for them with any sort of standardized test for them to practice having to read. There's so much of standardized tests is reading comprehension. So let's give them that practice with word problems and especially with chemistry. You know, I've talked about this when I talked about teaching biochemical reactions in episode 98 for biology teachers. But when we teach these chemical things, these things that are so micro for them, it's so abstract. They can't see it. They're like, what's a mole? What's an atom? Like, this doesn't matter to me. But when we teach chemistry in context, it creates so much more meaning for our students. So at the end of my stoichiometry unit, I have some review stations where they're going to review like all the different math they've done, but all in real world context. So I did a ton of research to make all these different things where they're going to calculate the molar mass for like a really complicated chemical formula. And, then they're going to apply that and do some dimensional analysis, or they're going to do some stoic with looking at fuel in rockets or, fuel in a race car. And they're going to look at how, kidney stones and the size of them and what size will determine the treatment plan, but they're going to do stoic when they do it. Okay. So I really want to encourage you to make it meaningful for them. I think sometimes we water down the problems so that they're the simplest math possible so that they don't feel overwhelmed when they look at the problem. When in actuality, by doing that, we make it harder because there's no context and there's no meaning. So don't feel like you need to water down every practice problem and make it, this really simple, find the mass from the moles of this. Yes, that's important when we're getting started, but as they start growing and practicing more and more, let's give them some meaningful practice problems that'll also interest them too. I try to make mine a little humorous. I try to put in little things that'll make them laugh or, get their attention. I like to catch them off guard. Okay. So I really encourage you to do that as well. All right. So those are my 6 tips for teaching Stoic. I want you to teach dimensional analysis and scientific notation early. And then I want you to review them when you start your Stoic unit before you dive into true Stoic calculations. Then I want you to start the unit off by helping them understand the mole. Please help them wrap their minds around that. And then I want you to scaffold all of your calculations, teach them one at a time, and then build upon it and do all of the practice. 5th, I want you to incorporate food or just some fun labs for them that will really just help them make this unit more enjoyable and not something they look back on and say, that was the hardest unit ever. They're like, well, maybe it was hard, but we also got to eat Oreos and make hot chocolate. And then we roasted these s'mores and then we did, make it something really memorable. And then last, make it meaningful. Give them real world problems. Give them context for the chemistry. I promise it'll make a difference. And I hope that these kind of tips encourage you as you're planning out your Stoic unit for hopefully next semester. And I want to encourage you to also tune back in next week. We're going to wrap up this series of difficult topics to teach, talking about physics. And I'm bringing in a special guest to talk about this with me. So stay tuned. And if you want to check out any of those resources I mentioned, you can check the links in the show notes, which can be found at itsnotrocketscienceclassroom.com/episode 101. And lastly, I would love it if you're listening. If you are a chemistry teacher, stop right now, give this podcast a 5-star rating and write a review. It would encourage me so much to hear from you. All right, teacher friends, that wraps up today's episode. If you're looking for an easy way to start simplifying your life as a secondary science teacher, head to itsnotrocketscienceclassroom.com/challenge to grab your classroom reset challenge. And guess what? It's totally free. Thanks so much for tuning in, and I'll see you here next week. Until then, I'll be rooting for you, teacher friend.